Welcome student, welcome to part 3 where this is where we're going to be designing and using Cisco Packet Tracer finally. I hope you are still engaged in this course because I would like to teach you as much as I know and as I have gained through my experience and constant knowledge and me learning myself, and then teaching courses for you guys to understand cybersecurity more easily than people sort of try and make it complicated. It doesn't have to be complicated, it's already complicated enough, right? So let me explain to you how to use Cisco Packet Tracer and networking, which this is an absolutely great tool, Cisco Packet Tracer. So to make a network, we needed hardware. So the first thing we're going to do is take a switch. So we'll go to the left corner, network devices and switches, take a 29060 and put in the middle of the screen. Now, why are we going to put it in the middle of the screen? Because it makes everything easier. Let me zoom up a bit if I can. Yep, there we go. So let's make it easier for you guys to see. So switch in the middle of the screen. You can change the name, but I like to change like switch 01. Now in the professional world, what you would have is like a switch, like you would have like S06 384 and like S or something, C something. Basically what this means is like usually what happens is it's a switch on the 6th floor and the room number is like 384C. For C could be like the left wing, right wing, forward wing, barf, back, north, west, east, south, whatever, right? Every single company has its own calling for the switches and devices, because obviously if you have like a 10-story building and you're in charge of the network, right? It will be a impossible quest or a mission to find the device, right? That's why you have names and devices, and that's why I'll be showing you how to change the names of the switches and routers in the next video, because this is on the implementation. And the next thing I'm going to show you encryption and changing the host names. So let's leave it switch 001. That's what I like to do, 01 actually, and let's leave it in the middle of the screen. Now what we're going to do is take a computer. Right, so what we're going to do is place the switches. Sorry, I just did this again. Place the computers. Now for you, I might say PC 12345, which is absolutely fine. I'm just basically re-recording and using the same packet tracer file, or file and program. So it doesn't matter. Now what we're going to do is take cabling and click the switch. I'm pretty sure it doesn't matter if you click the PC first to the switch. It doesn't really matter. It's the same thing, right? So what we're going to do now is we basically have a network, right? What we could do, if you go to the PC, go to the desktop, command prompt, and type ipconfig/all. Sorry, I always mess up this command. And for Linux, it will be ifconfig. Right, so what happens is IPv4 address, as you can see, nothing is set, which means we cannot do basically anything. These are connected, connected by cabling, but they're not connected network-wise, right? Because there's no IP addressing, we can do basically nothing. So what we need to do now is, because we don't have a DHCP server yet, I'm going to show you one computer, and actually I'm going to sub 2 computers to show you how to sort of test the connectivity, and then we're going to sub DHCP. So what we're going to do is place a server, right? And we're going to connect it to the switch. We always connect to the switch. We never connect it to a computer, because computers only have one Ethernet port. You could do the expansions, but it's not worth it, because what's the point? You need to connect it to the switch. Okay. So now what we're going to go is to the PC, IP configuration, and we're going to do is 192.168.10.10. Now, why are we skipping the first 9 or 10 IP addresses? Why? Because what I do is I like to keep either the first 10 IP addresses or 15, or the last 15 IP addresses for services. For important hardware. So servers, routers, hubs, switches, whatever I need to connect, I keep it as a separate, not network, but like maybe you can say sub-network, right? So we're going to leave it static. Remember, it's static because DHCP is not configured yet, right? And now we're going to do is go to PC9, and we're going to do the same thing. We're going to go to desktop IP configuration, and we're going to set IP basically the same but not exactly, because you can see if you press enter, and as you can see, subnet mask fills itself because it recognizes the IP address we set. Now, the two computers, these computers cannot be connected with the same IP address. It has to be, every single device needs a different IP address, right? So we set 192.168.10.11, and this one has 10. Now, what I'd like to do is get the notes, which is here in the left corner, and set the IP address on the screen, which allows us to sort of navigate more easily. And we can move these around, they're like post notes. Let's move it there. There we go, that likes me. Okay, so now what we can do is go to the PC, command prompt, ping 192.168.10.10. And now what we're basically doing is sending from point 11 through the switch to the PC8. And now as you can see, it says ping statistics for 192.168.10.10. Packets sent received for lost 0% lost, which means the connection is absolutely great, right? And this, as you can see, it says approximate round trip times in milliseconds. As you can see, it says 00, which is absolutely perfect connection that we have. There's no disruptions. Right, now, as I said, DHCP. Why would you use DHCP? What is DHCP? DHCP stands for Dynamic Host Configuration Protocol. What that means, the IP addressing is basically dynamic and it changes constantly. So if you disconnect a PC from the network, you connect it back, it will get a different IP address, right? And what happens if, for example, why would you use DHCP? I think I've said this before. I think I've said like part 1 or 2. Now, imagine you have 100 computers in a network, and they're all basically set out to static, which means static means it doesn't change, it never changes. And for example, for whatever reason, the IP address disappears, right? We need to set it again by an IT technician and needs to be done manually. What does this mean is we need to go there to the physical computer or log into the computer, right, remotely, and change the IP address manually, right? And this basically means time and on efficiency. It's not efficient. So what we can use is let the machine do it for us, and if there's any problems, we can always connect it remotely and give it the IP address by ourselves, right? It's not a problem. But it makes everything so much easier if basically a computer can do it for a millisecond. I can assign IP address with basically zero effort, right? So in this case, we're going to use DHCP. So we're going to go to the server, and what we're going to do is basically go to IP configuration, because the server requires its own IP address because the computers basically obtain the IP address from the server, right? So it sends a request, it gives it the IP address back, and it assigns to the PC. So we need to make sure it's not DHCP. You can never ever set the server as a DHCP address, right? Never ever. Why? Because as I said, the server requires a static, because it sends the request to the server, and the computer needs to know what address the server has. So it cannot be dynamic. It cannot change, right? So any device, any switch, any router needs to have a static IP address. It cannot change. So what we're going to do is set it, because we obviously give ourselves some room with the IP addresses. So we're going to set it as to 2. And then change the subnet mask. Now what we can do is set the default gateway as well, which we just 0.1. And the DNS server, but we're going to leave the DNS because we don't really need DNS, right? So we're going to leave this like this, and we can close this. Go to services, and now as you can see, there's services. We have HTTP, DHCP, TFTP, DNS, and some other email, FTP, IoT, VM management, and some other stuff. We are interested in DHCP only for now. What we can do is what we need to do, is turn on the service. We can leave the server pool name, and we need to set basically the same things as we set for the server. So what we're going to do, as you can see, start IP address, and we need to change this, right? So we set from 10. Subnet mask is fine, leave as it is, save, and that's it. Close this, go to PC, IP configuration, DHCP, and it should say DHCP request successful. As you can see, 192.168.10.10, everything's changed, default gateway is also assigned. And what we need to do now is just go click. And this what we'll do As you can see, everything's successful, which means they go an IP address. So this one's got 10, this one's got 11, this one's got 12 or 13, other way, it doesn't matter. So we go to the server to check, make sure everything's working. So what we do is ping. Now what we can do is something called, use something called broadcast address. Broadcast means obviously you're broadcasting. So you're standing in the middle of the network and saying, I'm here, you need to reply to me now. And if you do basically 255, it's different than if you do subnetting. Subnetting is a completely different task. So we're gonna press enter. And as you can see, every single device, so 11, 13, 12, 10, every single device that has an IP address is replying to us. As you can see, so all these computers are replying to us. The switch is not replying to us because it doesn't have an IP address. It would reply to us if you would set the IP address, right? Because why it doesn't reply even though it doesn't have an IP address? Because we haven't set one, and obviously we're pinning the whole network, right? And because it doesn't have an IP address, it cannot basically message us back. But we know the switch works because all of these computers are connected to the switch. So the server is connected to the switch, and the switch basically sends the data through the connection that we have set. So obviously everything's working, and as you can see, it tells us the packets, it tells us the speed, 1 millisecond, which is absolutely nothing. And what we can also do is -n, and then we can do like 10. And thus, what this will do is send 10 packets or 10 messages because we basically told it to. So what it's going to do is send 10 replies to us, right? Now I'm going to leave this, we don't really need to know. It's just something to keep in mind. Maybe you want to send a ping of 20 times. Maybe you want to send a constant ping, which happens in Linux. If you want to cancel constant pinging, you need to press Ctrl+C in Linux. Or set a command. I don't know what the command is for Linux. Maybe it's the same. Most likely no. Okay, so as you can see, it's just going to keep reply till I get 10 replies. We can close this. It also tells you time, by the way, which is also important to know, because this means maybe the signal is quite not as strong, which means you might need to implement a repeater or a hop to boost the signal, right? So that's sort of it. I just want to show you one more thing. What you can do if you go to services of the server and go to basically config services, sorry, HTTP. As you can see, there's HTTP, HTTPS. What we can do is, because this is obviously a server, it gives us so many options. So we can just turn certain things off, or what we can do is host our own local host website, right? So what we can do is hello world, right? So if you go to a computer and you go to web browser and you type the IP address of our basically servers, which is 192.168.10.2, as you can see, it takes us to the website, right? Welcome to Cisco Packet Tracer, opening doors to new opportunities, mind wide open, and we can change all of this, right? So if you go to image, it's a Cisco logo. As you can see, it tells us the file here, HTTP, IP address, and it tells us the exact file, which if you go to the server, HTTP, as you can see, this is the picture. We can name the same file basically with another, we can swap it for another picture, but the file needs to be the same, file name, sorry, it needs to be the same, because if we don't, it's not going to work, right? Because HTML basically is very, very sensitive. I'm pretty sure PHP is sensitive as well. Basically anything, the whole programming world is very, very sensitive. So even though the name would be the same, it still needs to be the same file type, file name, and more, right? So that's it for the first sort of implementation video of Packet Tracer.